Okay, thank you. It is really a pleasure to be with academics and especially the faculty members. And it is an hotel FDP, no?
Yes, sir. Yes, sir.
Yeah, yeah. So I think at the same time, even in IIT Jammu also going on. And yesterday, I think more than yesterday or day before yesterday, more than 47 Atal FDP programs have been inaugurated by AICTE.
Yes, sir. Yes, sir. It's on Monday.
So,
they just did that inaugural.
Yeah. So it has created a really a great impact onto transfer, transmission, as well as sharing the knowledge using this wonderful platform that gave us, let us take it positively, because more than 2/3 of the population now through sero survey says that we have got our immunity, and that is why death rate compared to the population that we are having less than 1.3 or 1.5%, something like that. So there are many indicative, contra-indicative data are being reported, published, debated, but it is so difficult time. And we are just, it is a lull period maybe, as we are adding one to the second, means third. Wave is coming or going on in some other parts of the country. But at the same time, the kind of ambience that are created by Manav Rachana University and calling us from here to the very emergent area in which we are all involved, when COVID is also disaster, pandemic for the first time in the world, that pandemic is being faced. So in this, while COVID is going on, but talking something on hardcore matter on civil engineering related or disaster, I'm not going to give any definition of disaster, but few of the slides that which I'm going to show, they will speak of. And through various social media, especially in the Facebook, in my Facebook, many of these slides that which I am going to present with, they are already there. So nothing new I'm showing. It is simply same spices are there, only cooking different dishes, especially whatever maybe the taste, choice, and theme, and some that whatever is decided. So that way, I would say that I'm thankful to you for calling us. And so National Institute of Disaster Management. I would like to share my screen and some of the video also I would like to show. So how you are planning, it is up to 4:30. So first, it will be continuity, or there will be some break, short break in between.
So you can continue, and then we have the Q&A session after your lecture.
Okay. Now continuation till 1.5 hours.
Sir, as per your convenience, sir. Whenever
Okay.
you want. Yes, sir.
Okay, means it is better that because if you allow me to speak, I can speak whole evening or night. No problem. You stop me. So that is why now it is 2:37. Maybe after 55 minutes, I will give a gap of 5-7 minutes, and then we'll start. And then question answer mainly I will look at after that. But so that let us see that how we can proceed. And in between, participants, you are most welcome to interact. Because you know, online, of course, it is in a very interesting interactive mode. So you can write your queries or whatever it is. You can in between stop me also, and even you can stop me, and then you may, if you need some more explanation, whatever extent possible from my side. So I'll see to that. And also you can write some of your queries in the chat box so that they can be taken up as and when the main thing is not that because you are also teacher and I'm also teacher, so let it not be only one-way flow. Let it be an interactive session as lively as possible. Okay. Anything you'd like to say? Any other things that you'd like me to follow, or I can
forward to your
directly go to
presentation, sir.
presentation?
Yes,
I
sir.
can
Yes, sir.
call you. Please give me some. I may call anyone in between. I take that freedom to have a kind of interaction.
Yes, sir.
I'll see the chat box. I'll see the participants list, and I will exercise a freedom to call attention to anyone during my talk whenever I feel.
Yes, sir.
So that we can make it interactive. Okay, is it allowed?
Yes, sir. Yes, sir. It's totally
Okay.
allowed.
Okay.
I just changed the settings also of unmuting themselves. So whenever you're going to speak up, they can unmute themselves and have an interaction with you.
Yeah.
Okay,
Sure.
sir.
Because it is, we are in the same platform. You see, we are all colleagues here.
Yes,
So let us create that kind of synergy where we can really see. It is not simply giving lecture and timing is over. It is not like that, because it is a lifetime opportunity for each one of us to meet as well as to interact, and also to explore everyone's individual as well as collective way in the area of the topic that is given to me, or rather that which we are going to discuss about the disaster management. What I don't use much because it is for something else, because we are from the civil engineering. Here participants mostly they are from civil engineering, all the teachers.
Yes, sir. Most of them are having a civil engineering and structural engineering background, but rest, the main is civil engineering.
Okay, so it is nothing not unknown whatever I'm going to show, but in a different bowl, different spice I want to show. Okay, thank you.
Okay.
Let me share entire screen. Okay, is it visible?
Yes, sir. It is visible. Yes, sir. It is visible.
Okay, so I have taken because risk analysis and management of hazards. I think to engineers somehow these words doesn't appeal them much. Of course, analysis part is always there. Risk analysis and management of hazards. Each of these word, in fact, risk analysis and then management of hazards. In fact, hazards management is something that by definition, hazard means is something that which has the potential to do harm. But if an earthquake is happening in a big in an area where no habitations are there, then we say that earthquake is a hazard, but it is not affecting us much. So, but I took a subtopic on that. In bracket, I have written, you will be very much familiar with the word DRR, disaster risk reduction, because we as an engineer, we don't go for definition much. But at the same time, when it is a academic faculty development programs, where we know, I highlighted here, one is disaster risk reduction. And here I'm going to share with you some spices of our life that which is beyond pure academics. I hope I'm able to just give you the ice-breaking kind of jerk that I'm trying to give you. Whatever is the academics, yes, in order to get our degree, in order to give the grades to the students, we have to go through some of the basics, applied software, and then analysis, and then some sessional classes, examination, and then assessment and survey, what not we do. It is there all in the curricula that we follow. But we give them because it is for the degree and knowledge and wisdom transfer to the student from the teachers and institution side. But I say that what I'm going to talk about, it is beyond pure academics. Many of them you will not find in the textbook. And so, but it is all day-to-day things which we are not handling well. So those are the aspects that I want to bring before you. And each and every slide, they speak something. Again, I said that these are some of the screenshots. Who have not heard now, even from 3 years, 6 years, 7 years old child also know about the 3D printing, artificial intelligence. At least they have heard about the code word, or coding classes are going on 6 to 18 years old. So we are all now buzzing with all these things, whether it is 3D printing, whether it is AI, whether it is big data, blockchain, connectivity, whether it is digitization, whether it is IoT, whether it is nanotech. You know, now it is, our mobile has given now up to 5 nanometers, that whatever chip thickness is there, which we cannot assemble in our country, which is being done outside, because such kind of things or facility we cannot have. Even we cannot have even the facility to make the solar cell, which I'll come, all these things, which I'm showing over here. I'll give you some of this, which is civil engineers are not being taught these things until and unless they go through maybe some of the specialization or super specialization after MTech. Otherwise, none of this so far, you know, are being taught even, of course, even in the MTech level in civil engineering. But as and when, I should not say complexity, as and when we are evolving with technology, know-how, fast speed, and now 4G, 5G, 6G, 7G, and all these things are wearable system, or even LoRa technology. I'll show you all those, some of those things, not about the rudiments of technology, but mostly that where in our day-to-day life, we can see that we can use these things based on the basic knowledge and academics that we have gone through, whether it is civil engineering, structural engineering, or it is mechanical, electrical, whoever it is. Now we have to work together. You may know that the computer that or desktop kind of things that which was made first time in 1980s, like we saw for the first time in 1985 when graduating in civil engineering in our college, in Bengal Engineering College, now Indian Institute of Science and Technology. Just we saw inside the room there is a cathode ray tube, and we just saw only, could not touch in 85 when graduating. But now, you know, these things are available. So in those days, technology was only getting increasing the speed of the CPU, how fast, and that CPU has now, if you see some of the newspaper report or some of the news item, that speed, the CPU speed, not only that, along with that, 50, 60 more technologies are involved. 50, 60 more technology are involved. Some of them are this, and then these are all now being used in Industry 4, or even man-machine, machine-to-man, and something decision-making, and or early warning, whether it is earthquake early warning, whether it is flood forecasting, whether it is landslide mapping or landslide forecasting. A lot of things where we are using as some of this technology, which are just symbolized over here. Of course, it is some report that market intelligence covering 12 mega trends. These are the 12 number of trends that which market. So beyond pure academics, what I mean to say that what we are teaching for the students as per the syllabus, as per the whatever is there in the subject, we have to teach them. You are teaching them diligently and obediently, or whatever way the syllabus is being is to be covered. What is now being uncovered in the world of technology, know-how, and at the same time, while the CRASK issue is disaster risk resilience, then we have to make and mix a lot of things based on the fundamental pure academics that we are giving as a teacher or that our students are getting. Okay, so let us see that what is the context today. In short, I would say that disasters about what is happening, you are all now, every second we are getting updated. Even if you go through the Twitter only, simply, you will get to know what is going on every second in the country, in every affair. So taking care of preparedness and identifying vulnerable area, that is what we have to be more and more, technology. Not that everything can be technology. We have to use our brain power, or we have to use our thinking, lateral thinking, artificial intelligence, or main and experience gathering, collections, lot of things, identifying vulnerable area, which will go areas, whether it is land, whether it is building, whether it is tunnel, it is a breach. I'll show all those examples. And then use of technology and taking care of the vulnerable establishments around us. That is our responsibility, because I'm addressing, or we are here interacting with the civil engineering students. Whatever establishment, whatever design that we are making, whatever it is being constructed, and then finally, after they fail due to some natural or man-made or some other man-made plus natural event, or even climatological event, that because of that, when our establishments, whether it is road, railways, or buildings, tunnels, or metro, or transmission, whether it is communication, whatever is there. So that thing, we have to look at that. We have to take care of vulnerable establishments around us. That is a big responsibility. And I know that recently, last 2 months back, 1.5 months back, we had an interaction 3 days program with the Construction Industry Development Council and NIDM, and there we have been discussing about, along with the railways, roads, and then metro. So there are several bridges are there. So total count sake only, 95 lakh bridges are there in the country whose health assessment first, identifying that where they are and what are the health condition right now, that was being flagged during 3 days program. Now 95 lakh bridges where they are existing, that how you will keep a physical document of 95 lakh bridges. So when the technology that we are having about all these big data, blockchain, apps that we are developing, there are so many. I'll show you those things also, some of those things that were not 95 lakh bridges. If we plot them, see them, when we are able to see them using Google Earth, then we don't have to go for the satellite or costly data and process them. When even Google Earth, which is freely available, we can identify even a 20 centimeter, 30 centimeter object on the earth, on the rooftop, on the roads, or wherever it is, using Google Earth when you see, which is freely available to us. So we have used this Google Earth features even more than 11 years back to map the vulnerability. Main point is to identify the disease that which came upon to our establishments while it is giving in service and taking. So disaster part comes later. First thing is our establishments, what are the health conditions of that is to be assessed, which we have not done. So 95 lakh is a huge number, but when we use the combination of this know-how that now even school students are also familiar with. So getting at least location, physical location of them, like in Google Map, we are having all those things. It is not unknown, traffic congestions and everything, whether it is a restaurant you want, whatever you want, you give a search, you can get it. So similarly, what I would say that with the project work that we are giving to the students, you are giving to the students, you can take at least cognizance of these establishments in the campus or wherever in the entire country using Google Earth. I would be very happy to get this app, mobile app or a server data can be generated using Google Earth, and then using Google Earth, and then collate this information in Google Earth KMZ file or something, and then at least physical location we know. And we have so many people with smartphone, we can get at least a photographs, few photographs and video and all these documents. So I'll come with these things later, how you can do it. One thing is the technology enough we have created, but utilizing them in a fruitful manner or unfruitful manner is also one way of knowing the things around us. So use of modern technology, IT, IoT, early warning tools and all these things we have to apply and then make the life disaster resilient as well as safe, and we'll show some of those things. Then implementation of the lessons learned, some examples also I'm going to show. So on these four important aspects, I'm going to, what are the lessons that given us, and we have made earthquake resistant buildings and codes are there, earthquake codes and everything is there. So in that case, not only there are only code, there are many other things that which are not covered in the code, but with our judgment, experience, lessons, observations, records, and going to the historical evidence, historical, say, proof, or whatever the data documents are there, then what kind of things that lessons that we have learned and some examples how we can implement them again in our day-to-day life, maybe in the academic session, or maybe projects, or helping the establishment managed by railway, roads, tunnels, or whatever, even industry, factory, building, planners, how we can help, or we can help each other to get to know about the current status of our physical establishments, whether it is buildings, bridge, communication towers, and what are the new technology has come up as on today, that which have disruptive technology, I'll share also with you, that which has revolutionized in a way that that we can have a map, we can have a scan, we can have a records, we can keep a bookkeeping of our establishments around us in the country. Like I say, the 95 lakh bridges, if you use all this technology, know-how and everything that which is there here, we can do the job much faster than what we might have imagined 5 years or 7 years or 10 years before. So I'll come up with all those things. So one part is that just you look at this one, just you, okay. That how, because now this is a rainy season across the country, in many parts, not only country, whether it may be in Europe, it may be anywhere, flood has been causing havoc around us. When it is causing, then there are certain solutions also we have learned, we know, we handle and teach. We also make examples while teaching the students in the class. And it is not only that going through the formula books, derivations and examples in the book, those examples are also we create with our own skill to the students, so that it is not simply just like competition or preparation kind of things. While going through the questions also, then we also show to the student to appreciate the question being asked, rather than which is the right formula to be used, so that you get the correct result. I think there is a tremendous change in the way of communication to the students and way of transmission of the subject to the students. But thing is, an example like this, just these are the houses that are here. Well, these are the houses, how they are being protected. So I do not need any description, but who has done this? For them, or some of them, or the concerned, whoever looks after the river. We have various ministries, various departments in the state government or UTs, and also in the central government, Central Groundwater Board or Flood Central Water Commission, and many such organizations are there. And India Meteorological Department, they give the forecasting. And also Central Water Commission, they look at flood forecasting. But forecasting is one thing. Flood routing options, potential storage using membrane, I'm going to show some of those things, that in order to save these people who are here, who are in the low-lying area, I think we don't have to teach, or we don't have to explain that how this primary protection, how nicely, without using any retaining wall or concrete or anything, how they have used the local earth as a levee or dam or embankment, and with such a way that this is the primary protection. Secondary protection, which is being done over here, which is very much clear over here, that flood routing means whatever water is coming through this, you see, it is being routed in this manner to this site and this in this area, so that this area is protected. So these are there in our civil engineering domain and discipline to ensure, because mind it, I started with disaster risk reduction. It is not that making house, yes, everybody knows how to make the house, but protecting them in their service period we should not take right now in the context as an extra responsibility. Extra responsibility for taking this extra responsibility is again lie with some organization and some people who again born out of our civil engineering discipline. So it is hydrology, or you can say agriculture side, or you can say water resource department, but finally the levee or other things, you must have certain solid knowledge from the fluid mechanics or hydrology or water and how it is flowing and what are the kind of strength that to be given, and then how this can be made stable. There are 10, 15, 30, like say computer technology was only increasing the speed of the CPU in 1980s, which has gone into now more than 100 such related technology, whether it is Wi-Fi and whether it is VLSI, or so many things are there. So here also there are so many disciplines have to work together with a synergy. Ultimate aim is protecting these people. So I hope no need of further explanation. But when it comes to a local area, when it comes to, especially in our urban city, when it rains for 1 hour, 2 hours, 3 hours, our locality is getting flooded. And these are sandbag type of things, but actually they are not sandbag, they are sand inside, but bags are polythene. Bags are not made of jute or cotton or whatever you know. Otherwise, it would not have stopped this water So it means that the gap and their weight is such that which are manufactured, these polythene materials are available. Geotextile, it is a petroleum byproduct. These are available in the market, plenty. Only our job is to choose the right variety of bags and make such kind of bond, such kind of barrier so that the water doesn't enter into our working area or into our living area. So that way, I would say that not only this kind of things, which is traditional one, but sophisticated one, not a single drop of water is coming over here, this side. You see, you can see here, not a single drop of water is coming. So what are these things? It is, yeah, rubber gasket and this kind of stand which you have to put it, and these are to be placed, these are to be used here very, very judiciously, and all this package and everything, all material, these are all available in the market, and we have to select this material, looking at that where flood water is coming. So here again comes the role of, again, not that all engineer, but here community can help, their wisdom, their experience, even those mason, mystery, or whoever that we can extend, or not that only civil engineer from a very big institution, the gold medalist has to come in. No, here lots of common sense that who are experiencing such kind of water problems, especially during heavy monsoon or rainfall, or in the city area, which even many European country or even many other countries they are facing. And so in that case, some of such kind of measures to be taken in a manner that which is being shown here. You can see many such examples are there. Aqua dam, many such examples. Otherwise, once this is not there, this is not being protected, you can think of the kind of damage due to the damping and the future effect of this damping, which of course no one that who are living in this area or in our house, think of our own locality and establishments which get inundated. Only this portion is helping us to save ourselves, to bring resilient measures, which will come into definition again. Some kind of resilient measures is being taken up by Aqua Dam, which are again the products is not from that something that which is to be manufactured. Each are all available in the market. Only depending on the problem that we are seeing, that how much water comes, how many hours, which day, which period, what time. We have got all this mobile-based, early warning and everything, forecasting and everything is there. And even we can see that satellite photo, Google photo, so many things we can see. But when we come for the implementation, please mind it in the context that I have written. Implementation of these things should not be compartmentalized in a manner that, no, it is his job, he has not come, let me complain, let me call police or 100 or 102 or something like that. No, this is the where that risk analysis is one part, the topic that given to me, but implementing something out of the box, out of the common sense, the problem being faced is the urgent necessary skill to be inculcated, whether I'm a professor or assistant professor or a school teacher or a school principal, or even those who are in the society have to make such kind of measures to make a greater goal of resilience. Aqua dam or something like that, these are all maybe filled up with water, or they can make heavier, and then so that water doesn't come. There are many such devices available. Even we can make a road which was functioning, but we can keep the road functional even if water level has increased. So you can see that road was there. This is 1 lane, this is 2 lane. This is 2 to 4 lane. But in an emergency purpose, just to keep one lane functional. And you see that this is a median yellow color, to keep at least one lane functional when flood water has come over here. So such kind of aqua dam, whether you can fill it up with water, which are resting on this on its own weight, it will not allow water come here. So this is a very real application of keeping a communication alive from this side to that side. So in that way, I would say that this is how we have to come out of the pure academics to save our society, to make people, to make our living condition sustainable, resilient, lively, as well as save this from the kind of problems that we face, where this is hazard, no doubt, but making hazard not to create a disaster, not to snap the communication from this side to that side. It is our earnest duty together to make it functional. Okay, let us say that let us keep these things in mind, that safety tank we are using in every household or even office complex and everyone. And for civil engineers or even diploma holder, it is not unknown that how how a safety tank, how much money we spend in making a safety tank for a building, maybe per family of 4 or 5. And what is the function, how it inlet comes, and what are the sludge being created, maybe after 10 years, 20 years. We have to needs periodical evacuation in case no drain, more frequent. In case no drain is there, frequent evacuation is required. And you know that it is being traditionally, we make our safety tank like this, and it is to be below ground level. And of course, it should be below the whatever the inlet, and it should be whatever near the toilet or whatever facility. And for that, planning, configuration, and then its amount of money required, construction effort to be required. It is all being known. You ask any Mistri or anyone that you want to make a safety tank, and now component-wise in a building, in a flat, everything is, per square feet. Or if you say safety tank, they'll have certain shortcut measurement. Based on that, they will say that, okay, safety tank, this by this feet, this feet by this feet, itna garai hai, ye hai. So we need, this is the amount of money. So they will give you that each and everything, like in our computer also, this component, everything they know in market, what is the price, what is this price, and everything. There may be 50 components over here, which you can make computerized list, and price is known, and whatever schedule of rates that available in CPWD manual and everything, it is there. So automatically you will come to know that each and every component, what is the price, what is the construction, and when you approach to a local Mistri or the contractor or anyone, they will simply say that, okay, 4 feet by 5 feet by 5 feet, okay, this is the volume, this is the amount that you have to give me. Rest, it is on me, and I will give you all standard materials and everything. So over 100+ years of our sophisticated designs, or the codal provisions that are available for last 50, 60 years in the country, we are very first meticulous, particular about the quality, surveillance, services, construction, cost, time, everything. If you make all this component, it is all known to us. But what I want to stress on this, the sludge clearance. Moreover, now to this day, now we are taking some alternative to this. Alternative to this conventional one. So conventional one costing for a family of 4 for one safety tank, it may cost something, say X, maybe say 2 lakh, 2.5 lakh or 3 lakh, whatever it is all considered into that. But same volume, if you use this material, same volume, if you are using this material, what is the cost? Can anyone tell us among these participants or whoever? Can you tell? Now I wanted some interaction because it is nothing hi-fi things I am talking about. I am just taking you beyond pure academics, that if it is say 10,000 square feet, means if you say, no, not 10,000, if you say feet wise people remember, but if I make it meter, say 3 meter by 2 meter by 2 meter. So it is 12 square meter, and reduce this everything. So it will be 10 square meter, you can say, a 10 meter cube. So 10 meter cube is 10,000. 10 meter cube, 10 into 1,000. So 10,000 liter. So 10,000 liter. How much is the cost of a syntax type of water tank that which is available in the country? 5,000 liter. Per 1,000 liter, you can say on an average 5,000 rupee, standard one. Syntax may be 7,000 rupee. So if you make 2 water tank and 5,000 rupees, syntax water tank. So if per 1,000 is liter is 5,000, means 1 liter is 5 rupee you have to pay. So for 10,000, you have to pay 50,000 rupees. If you make a standard product available in the market, online or whatever, offline. So 50,000 rupees. Whereas similar thing, if you make here, it will cost you, of course, it's sludge and everything, all these things taken care every 10 years, maybe you have to do. So it is costing you how much? Maybe 2 lakh, 3 lakh, anyone can say? Sakshi, Katia, any idea? For a safety tank like this, 10 meter cube, 12 meter cube. Nupur Verma?
Yes, sir.
Kitna,
Am I
how
audible?
much you think that for making a safety tank, generally, I think not less than 2 lakh. I don't know exactly, but if I make this comparison, then anyone can tell that how much money usually they charge for in the conventional case.
Yes, I think it should be costing around that much only.
2.5, 3, depending on what quality again. If you want
Yes,
to make
depending upon the materials and the, yeah.
like they make rainwater harvesting chamber also like this, no?
Yes, exactly.
So they also charge minimum 5 lakh conventionally. But what I'm talking you that with this geomembrane, instead of making this concrete and other things, concrete means brick wall and then make plaster and then should not leak here, all these damp-proof coats, everything you have to pay. But when you put membrane into this, so or if you simply put 5,000 liter to 5,000 liter safety tank, just make only cost which is required, something that you have to make inlet outlet and you have to excavate this. It should not cost more than another 5,000, isn't it? So 50,000 to 5,000 liter syntax good quality tank, put them together, they will do the same function over here, isn't it? So these things are conventionally for hundreds of years we have been doing. But with this kind of material that has come, here, the sludge that which is taken over here, you cannot lift this. You have to carry them, you have to open and you have to make. Whereas if it is a tank, safety tank means ready-made tank, you can simply take the tank and then discharge it wherever you want, and then again bring it back. So it will not disturb the local area. So there are many advantages are there. At the same time, when it is costing 50,000 for a finished product, this kind of membrane is available from say 50 rupees per square meter to maybe 500 rupees per square meter, depending on the thickness, quality, and usage that where you are. So if it is say on an average 100 rupee per square meter, so for you can see that for 1,000 liter, it is 5,000 rupees. Whereas if it is 100, just make a cube, 1 meter by 1 meter by 1 meter cube means 6 faces. So 600 rupee only. So 600 rupee is the basic cost of the membrane to make a 1,000 liter cube kind of thing. So you can add maybe another 500 rupee for the making it stitching, bonding, and everything. So cost has reduced from 2 lakh to 55,000 to 1,000 rupees, means you can say 5,000 rupees or something like that. So the revolution that which has got this membrane, it has made our the most conventional method of construction and usage in a revolutionized way using an alternative material. Like you see, this is in use, something like this. Wherever you want, you can shift this one wherever you way. It is doing the same purpose that traditionally that this has been doing. This first, when new construction we start, we make the safety tank first, safety tank chamber and other things. You see, this is what is the chamber we do. Later on, we make a slab over here, make a safety tank, because you have to use it for storage of the water for construction purpose, something like that. So the conventional one is this one. Through drain, we take all the semi-solid sludge and everything we take to the sewage treatment plant. And you know that what is the effectiveness of sewage treatment plant and how they operate and how to maintain them and how to keep their health system again intact. How to make their health system intact, and which, you know, in majority of our city, we are not in a position to maintain as well as up to the capacity they don't run because of the many operational as well as the technology. I will come to some of the disruptive technology that has come up in the market, which this kind of system is conventional for as long as we have been doing in civil engineering and environmental engineering, STP and activated sludge process and aeration, all this through process that we do. And finally, we leave them polluted, untreated water. Here we do aeration and all processes are there. And finally, we put them in our river. And these are not drinkable. These days, of course, by some rule or by rule or law or action, say that you use it in the garden or sprinkler, but we cannot drink it and we cannot make it. We cannot ensure it, despite entire the process is involved there in taking this sewage collection, and you know how it is being collected and how it is being treated and what happens in the surrounding area and what kind of smell comes in, and we are familiar with. But even though we know it is a hazard, but we don't know what kind of disaster that it is causing into our own health. And COVID has exposed all these things. But I will not go into that area in detail. Only thing is that in all these things where civil engineers are involved, civil engineering fraternity are involved, at their construction, design, operation, maintenance, and finally releasing the treated water into the river or even in the ocean or even in some other places, or maybe forcing it to use it in the garden or some other places. In all this process, I think no one other than our community, I'm saying a community, ourselves, know that what are the health hazards that they are causing despite spending so much, despite our research, despite our academics, despite our applications, experience, operations, everything, whether it is SCADA system, whether it is surveillance system, whether it is IoT device, we are checking, we are monitoring their quality, we are checking their BOD, COD, before, after. Whole operation involve hell lot of activities. So now you see that what is that for the last 10 years biodigester, flush and forget drainage system, where this make a sludge. This kind of biodigester now they are being implemented in many public toilets and many places, office complexes, even in train and compartments and everywhere. Biodigester tank. Here it comes only plain water. So the point of talking this thing, it is not unknown to you again. Conventional, please mind it, conventional to this system, even if it is costly, slow, or taking time, when this is causing so much of health hazard, which is unknown to us, and we are nurturing a lot of disease, causing pathogen into our system, into our ambience, into our surroundings around the hospital, inside the hospital, and we do test after test and everything. So the entire gamut of this disaster risk reduction, you see, all these things comes under that domain. That is why just I wanted to make it. So rather than going for this kind of things, then even we have to go for this kind of things so that we can have a total safety, like in case of petrol, diesel, CNG, or electronic vehicles or electric bikes, that we are shifting towards that. From conventional energy using thermal power, we are shifting to wind and solar. I'll come there also a little bit later. So biodigester kind of things, we have to do a lot more research. This is DRDO technology, and DRDO technology came up, perfected more than 10 years back, but which gives clean effluent, whereas this gives effluent that which is giving over here even after this kind of treatment is also pollutant enough. Only we manage that, okay, BOD, COD, or DO and all these things are within limits, so we can release it in river or some other places. No, we have to change this thing. We have to bring such kind of technology where as an outlet we get clean water, so that we make ourself, our life, our living free from all this impact that causing. Yeah. So there are some disaster database, human cost of disaster. You will see many such, like COVID database you are having, you can see total disaster events 2 decades before 2000, 2 decades means till 2019, and comparison you see. Very nicely these data are being presented with each and every signage that which are being used: drought, earthquake, extreme temperature, flood, and then landslide, then of course mass movement, dry, like erosion and other things, or even sandstorm or storm, volcanic activity, wildfire, to name few of them. There are more than 30 plus such hazards are being recognized in our high power committee and also indicated in the Disaster Management Act 2005. Then rules came up, many guidelines came up. So you can go through those. Disaster Management Act 2005. In fact, RTI Act also came up at the same time, December 2005, because urgency came after tsunami and Gujarat earthquake or Odisha cyclone. some of those events. So decade means 2 decades, 20 years of comparison is showing over here that currently all these numbers are increasing. All this number you can see there in an increasing trend. So would you go through simply that this number, 1457, and then it is 2043. So while we are teaching the students in the class, so what we have to look at that not to memorize this number, which we have to see that the trend is more. So we have to be more concerned, not only concerned, we have to take some appropriate action. So that action, one of the many such action is being highlighted over here. So what we have to see that all these things, the number that which is increasing, is it an index or it is an indication of the development in technology, or is it taking care, or there are many kind of reports are being published by human development index, happiness index. There are many hundreds of such reports comes regularly in the form of some authenticated publication, like we make India disaster report, India disaster, world disaster reports are also there. And there are several conference seminars are being held, which you might be familiar with. But thing is, everybody, like these are being shown over here, colorfully, pictorial wise, but because the topic that we are discussing over here, we create the establishment, we design them, then they fail, and then we go there as a post-mortem analysis, a back analysis. So we go there, then finally, what kind of resilient building, if similar event happens again, then whether we have reconstructed the facility to be able to resist if similar event or even bigger impact is there or not. So that is where our responsibility as a civil engineer, after passing out from the corridor of academic institution, we have to take care of such kind of responsibility in the name of our services to the society in whatever position that we are having. So this is what that together that we have to understand beyond academics. And whatever historical events you see, according to Greek mythology, the giant typhoon is buried under Etna volcano in Italy. Then whenever the giant stirs, the volcano erupts violently. So it is taken from the history of volcanology, you can see. So there are many such memoirs according to Greek mythology that giant typhoon is buried under, same thing, Etna volcano, whenever the giant stirs, the volcano erupts violently. There are many such myths are there. Now let us come back to the this aspect about the earthquake and directly what kind of impact that primarily that it causes. It may have a landslide, it may fill the dam, building collapse, train may be derailed, wrecked, utility malfunction, tsunami, we know, 2004, 26 December. Then secondary, when landslide happen, along the landslide, building collapse, utility failure, and so many things happens. Okay, so I think let us take 5 minutes break. Then we'll start, because it is just now we are starting into that. I may take another 30 minutes at least, minimum.
Yes, sir.
Sure, sir.
Okay, so we can take just a break until that. Okay. Okay. Can you start?
Yes, sir.
Okay. So welcome back. Oh, it is, I am at the 8th number slide just now. There are so many other slides are there. So these are all primary, secondary, tertiary effect, and things can happen, we know. But how much of academic, just due to one event only, earthquake, we know about the occurrence of earthquake, where they are strong, where they are zonation, microzonation, then earthquake resistant design, testing, and then teaching earthquake engineering subject in civil engineering, MTech level, PhD level, and then seismic microzonation, and then these days base isolation devices, even damping system, damper system, and in base isolation also several types are there. And then earthquake resistant construction codes, building codes rather, IS 1893. There are several versions, variations are there. Then mapping of earthquake hazard is there, which are the area that, like Delhi is in zone 4, and all these things are there. So in that case, we have huge literature, but just think of one such application or one such aspect that which gives hello. Okay. ओके मैं 4:30 अभी मेरा लेक्चर चल रहा है 4:30 बजे. So just think of all those knowledge, building codes, and what I have mentioned, seismic microzonation. Just simply dam construction we do, dam failure also happen. Use all those knowledge that how dam failure is going to occur when it is the most important structure in a design. We design it, still some failure happen in the primary cases, and then see that how to accumulate all our knowledge, know-how, wisdom, code, building codes, guidelines, teaching, experiments, and that a dam failure caused by earthquake, and that is causing flash flood in the area. When you will deal this subject, this area, from the basics of disaster risk reduction, risk analysis, despite we are familiar with all this technology know-how, but the transformation, I would say that conversion of an earthquake as a hazard, then to a dam, which is the civil engineers' most, most, I would say, dam construction, reservoir maintenance, and releasing water, producing hydroelectricity, and then many and erosion control, and then canal diversion, electricity productions, and reservoir water level, and the drawdown effect. And there are so many things that we have to look after. Just so many things happens with dam, and still we construct because it is mankind's. We have over the thing to store water, drinking water, or even irrigation purpose and other things. It is not unknown to us. But my main concern is, despite that we take pride in making dam and servicing some of the dam for 100+ years, 200+ years. And we have around 6,000 dams, which are generally 15 meter and higher height in our country. Worldwide, several lakhs of dams are there. Despite we have mastered ourselves in the construction of the dam, and then reservoir, then survey, preliminary survey, so many things we do. But when an earthquake, and taking care of earthquake effect also into the dam design, according to the zonation, we use some factor over there. Even then, an earthquake caused a failure, which is though rare, but when transformation from a dam failure to the downward side, downside, when dam failure occurs, mean all the water will come down, then there will be fresh flood, then so many things will be taken away, and utility malfunction also will be there. If you take only this vertical along this, just think of the kind of knowledge and wisdom, knowing, expertise that we have gathered, we have procured, we have made available at various sources in the library or in our textbook or in our class note. Make all together and just mix it up, make it a spice, and see that which area you are or we are able to explain, not for giving a lecture, but able to relate and find out the cause and then take appropriate action before, so that such failure are minimized. Not that we cannot stop the things, but we can minimize. So that is where that whole spectrum of disaster management is there. Hello. Sorry, sorry. Okay. So think in that direction. Not that I'm having 2 PhD or something, this direction, 135 publications, this, that. Those will not count anywhere until and unless all our wisdom that we are gathering day-to-day life from various sources, various utilities, various kind of gadgets that we are using, we have to make our duty that where the transformation, especially here, that at this stage when transformation is happening from one type of failure or one type of disaster or one type of hazard to another, transforming to another one, fire explosion is happening, then it requires all those experience, expertise, lessons learned from elsewhere, some others example, like few example I have shown in the beginning slides. There comes that our own resilience, and in the name of the country, location, city, wherever we are living, or village, or in a flood-prone area, or in earthquake, wherever we are living, how much resilient we are. That is where that the taste of our earning as well as disseminating our wisdom, just not by word of the mouth, but by our own resolution to act and also make infrastructure, like in our context, that infrastructure resilient enough under the banner of disaster risk reduction. So now let us see some of the effect that April 28th, 29, Assam earthquake, that which is the recent one, that which caused this kind of signature we saw on the ground due to this earthquake. This we have, what is this we call? Anyone Mina, anyone can say that what is this scenario called in our civil or geotechnical engineering? Anjali Gupta. Anyone who would like to say? So I can see there are about 40 plus participants. No, I am not treating you just like a school kids or anything. Just to, I am speaking to my computer and so wanted your action, reaction, something you should disturb me.
Sir, there's an answer came in a chat box. It says liquefaction.
Oh, okay. That is called liquefaction. Yes. Where is the chat box? Okay, I want to see that. Oh, yeah. Participants.
Hi, sir. Since this is a sandy soil, I can see the soil is liquefied. Protection of the soil.
Ma'am, your voice is breaking actually. It's having a lot of noise in the
My
background.
Okay. Okay. My voice is okay, clear?
Yes, sir, your voice is fine.
Okay, this is exactly, it has happened, some liquefaction. That is what we say, the liquefaction, we know, the things that which we see that it is called liquefaction. Do you think that simply that a liquefaction has occurred over here? So, which is for a 6.4 earthquake, 6.4, which is not so big, but ground has behaved in this manner. Had there been some building on these, then what would happen to them? So the most important aspect of liquefaction, that which is very much well known to the world, I think all of you know, in which these things was the signature. This is recent one, and this is the signature of ground sand boiling or things that has happened in Niigata earthquake in 1964 in Japan, and where you will get lots of details about this. Nothing happened to the building. But my query was, if there would have been some buildings, so some phenomena somewhere else, even though building constructed geometrically, you see, there is no protruding baranda or anything, you see, there is nothing like this. It is all geometrical place, so that they know the earthquake prone country, entire Japan. Even then it has failed, not due to the structural failure, which we concentrate that earthquake structure, building damage or building kills the people, not the earthquake, and a lot of things we know. But nothing has happened because foundation became weaker. Foundation gave in due to the excessive vibration which has caused a phenomena called liquefaction. I'm not going into those details because these basics are being cleared, and you know. But showing again that what this earthquake has caused, some of the building which is more than 100 kilometers away in Guwahati city. Just now I spent more than 10 minutes in this. So just from there, coming to this photograph, did this building showed, even though it is in zone 5 area, any such response to the showing, like, you know, it is, did it show any kind of resilience or like a structural design, earthquake resistant design? Did it show? No, nothing. So in that case, the buildings that which are made in seismic zone area, you see that our responsibility, our accountability is also there. 20 buildings like this got severely affected. Almost 100 buildings showed crack and other thing. So it is again a number. Oh yes, it is only 20. But question comes here, when an earthquake happened, even of this much magnitude, 100 kilometers away, how come it can affect a building 100 kilometers away. The magnitude or energy being released by these depends on, again, the soil conditions and other things. So those details are in fact dealt with in seismic microzonation, especially for Guwahati city, which is being done more than 10 years back. But microzonation has been done, that is one aspect. Taking microzonation aspect into the building code and taking building code provision into the building design, there comes the problem. This is what, in fact, I wanted to highlight, which you know, nothing is new. But living in a city, sometimes we have to make our infrastructure in such a way that to facilitate, facilitate such kind of things in maybe building made by somebody else. So which is also a great example of, community living in a city area, or a cooperation or mutual understanding of facilitating a traffic in this manner with whatever rules, regulation, bylaws, agreement, safety. More thing is, when cars are moving over there, there should be some kind of soundproof. There should be a lot of things are there which is to be mastermind. We have to be having a mastery of creating such a facility in a building which is made for maybe living or maybe some office or some other purpose. So it is also one kind of surgery, I would say. It is done such a nicely that it is operational and it made the traffic system better, something like that. So living in a city or living in the country, when many events are happening which are caused by nature or even caused by man-made cause, at the same time, we have to give our shoulder to live happily, to live with a coordination, with to live with harmony in a family level, individual level, community level, city level, local level, all these things that we have shown a lot of things. A lot of such establishments are there in the country. And finally, what we have to look at in the context of this, that the facilitation, like urban infrastructure, these are not being taught in a textbook, but these are to be taken, such kind of projects or such kind of work, when our students come out of the corridor of the academics, then when they join a company or something like that, then it is not simply a structural engineering design they have to look at, they have to coordinate with here so many other departments and other modeling also they have to do, vibration modeling, and then pollution, and then many other things which you can think of. So we have to bring them slowly after giving basic training, then we have to bring them to the world of practice, which has to have a sound understanding about the aims and objective of creating such a facility and its short-term, mid-term, long-term implication to the society, environment, and overall the impact of disaster, like in Japan, it is earthquake, whether it is safe or not. So the whole paradigm of disaster risk reduction, in fact, we have to take it beyond the classroom while dealing with such kind of things. Like one such things, now I have shown you all good things that all where, we have to work together. We have to work together, think together, act together in synergy while making our infrastructure sustainable and whatnot. So nature creates hazards, but the action of people, societies, towards whatever governing or ruling or system or society means community, people, and our willpower, the example that which is taken over here. So I would say that creates disaster. But why I'm saying like this is a 2 to 4 lane road in some place. This is in our Delhi itself. It is under construction at that time. Metro photo is taken anytime. Mulchand flyover is also there. Metro was under construction when this photo was taken, and this is also functional. And in fact, it was made maybe more than 10, 15 years ago. This was constructed, took more than 1.5 years or 2 years of time while making this underpass. But now it is a smooth traffic over there. But in some other part of the city, the same kind of underpass, which you can see near airport, it goes, means something that which is very much mandatory during rainy season is the pump system, drainage system. Of course, it is another area. This part also get drained sometime getting this kind of inundation where you can see it goes out of order. So who will take care of? There are concerned department, agency, organization, equipments, pump or whatever facility draining them or whatever anticipation of this kind of water inundation and then taking appropriate action in time. All these things comes under serviceability part, and they cannot be separated out. They have to work together in unison with the problem that we are likely to face, like the way that it is vivid work here. Like this one, this is a recent one in the month of June itself, that in Chhattisgarh, near that. When it has rained, it is a rainy season, it is going to rain. So such bridges are there. So when water has, you see that there is no water over here. Here it is water. So rainwater coming over here, and then it has caused piers to fail because there may be, because of the water, there is no investigation, and everything became some other ball game that which we do not want to discuss over here. But ultimate thing is that bridge construction, people that are to be blamed, because in design, in bridge design, cover design, or this kind of pedestal or this kind of pier that which we are making, we take all safety factor into consideration, and also in case of water and the kind of scouring and other things we take care of in our design, which is there for the last 50 years in our design book, textbook. Even it is being taught at bridge pier and other things. Even then this has failed. So it means it is not that design has failed, but in the lifetime or service period of the bridges, when this water or rainwater is going through this during service period, something started eroding, something went wrong, something got unnoticed, resulting into such kind of things. So every such event gives certain indication. So any structure that we are making, whether it is a bridge or building or everything, we have to see there during the service period, is there any sign, is there any show up, or is there any bad thing are going to, or is there any erosion like in this case happening? Is there that scouring is happening, or is there that whatever components are there getting deteriorated, or their strength is being reduced? So that part we have to look at. So finally, come to that disaster resilience, where the impact happens, then immediately we go for the relief, and then all the recovery transition, then reconstruction part we do, which we have discussed all these things, because and then risk and vulnerability assessment. This is where that we are looking at. Then risk reduction. In fact, whatever discussion that in the last 1 hour we have been doing, we are looking into this aspect. That whatever examples that I am showing, these aspects that we are looking into, how to check the vulnerability and how to assess them, and what are the way that we can avoid them, or we can say that even if it is happening, that how to make it resilient enough. And in that way, high in the, whether it is a governance, like I gave you some noting that it is a people, society, governance, they create the disaster. Hazard as such is not. So it is governance, it is society and economy, it is coastal resource management, it is land use or structural design, it is risk and knowledge. About this also we have discussed. It is warning and evacuation, something like this, or it is emergency response, how early we are giving response. So it is then how early we are getting recovered from a disaster. So this is the entire gamut of disaster management, you can say, in a different way. You will find several such diagrams to describe that what disaster management cycle is. But our emphasis over here is if we are good at, like here it is at 100%, if you say this 20, 20, 20, 20, 20, 50. So it is 100% here. So if our measures, we are able to measure in terms of governance, of course, we know that we cannot be 100%, but we are at 100%, we will be in a high resilience. If we are somewhere here, for this, if we are here, so for this we are here, for this we are here, this knowledge we know, if we are here. So something like this, we can estimate. Now we are coming into quantization of the, quantization means getting information, proper information on our palette, so that we can have our thing decide that where we are. So this is where that our analysis, our data collections, and then evaluation, putting them in a diagram, that then how much resilient we are. So in totality, that we are able to check our current status. So, but what are the emergent issues? Rapid and often unplanned expansion of cities is exposing more people and economic assets to the risk of disaster and the effect of climate change, which I hope you agree we all are familiar with. Like here, people here actually all this, society and economy. So all the keywords are this being represented in this diagram. Some way or other, they are coming over here, like these photographs. It's taken from in our city area, where you see this one, this portion. If you see that that how many live wires are going and how they are making, and also see that in the name of construction you see these, or here you can see, and the kind of here you can see. So all these things are really, really crucial in giving a stamp or giving a certificate. Now these days, it is in great demand, that structural safety certificate. And these are all available in the market. There are so many agencies are there, they'll give you certificate, like the way we have been doing with affidavits and many other things we give in affidavits and things, or while in registration process, and many things we give. But for structure, for buildings where people are living, where shops are there, essential facilities are there, roads are there, where commerce and all these things are going on. These kind of things are also there. So when a community is living over here, who can give a certificate of safety of this kind of structure, this kind of things? Is it like that, just simply that you put a stamp, okay, give me some whatever fee is there, and then give me, okay, see the drainage system over here, sewerage. And what happens when it rains here, all the sewerage that which comes from this kind of house, most often, they are all mixed together, and then they go directly to our main urban drainage system, and then you know that how they are being treated. So giving a structural certificate or safety certificate, even in seismic zone area 4, having microzonation, having 7, 8, 10 codes are there, earthquake related codes, and having expertise and teaching all these subjects in our classroom, even building codes, all sorts of building codes, whether it is wind code, whether it is earthquake code, whether it is concrete, and there are more than 2,000 civil engineering specific codal list of codes are there in Bureau of Indian Standards. Despite having this information that this, despite having all this knowledge, expertise, where we are having number of committees and subcommittees, and then we are dealing with so many things. But if you come to define the safety where the corner doesn't have any column, and because their economy, the local area, land uses, so many things are there. This, we may say simply that, okay, these are unauthorized construction. But by saying that unauthorized construction, these people have built up their own whatever might, or whatever economic power that they are having, or whatever way that they could think of that make another floor or another story, making all these things. But how they are going to behave when an earthquake shaking will be there of intensity 6 or 7? Who will estimate this? It is again our responsibility to estimate this. Whether this work is given to us or not, let us shed off that kind of spirit. But we have to say that, or we have to inculcate this vision in our mind, that the kind of establishment over here, which we are seeing in the hazardous prone area, where health hazards are also involved. So this makes our life in city really a mess. So in that way, the word Sendai framework, actually DRR became famous in the Sendai framework 2015 to 2030. It started in all the countries signatory, and all problem lies at the interface. This is what I said, like when dam failure due to earthquake turns to say flash flood. So flash flood and dam failure, there is an interface there. Problem is there, how a dam failure is turning into a flash flood. So the different department will be working, different experts will be working. Dam failure, when it is happening due to earthquake, there are a separate group of experts that will be dealing with this subject. But ultimately, earthquake is the hazard, but earthquake caused the dam failure, which I was describing previously. So the meaning that all our knowledge, know-how, experience, economic mind, or locational advantage, and our whatever facilities that we have, all comes into work, have to work together at the interface. And in that way, what is that we are looking at? In academics wise, we are familiar with all this: fluid mechanics, structural response, thermal transfer, electromagnetics, magnetohydrodynamics. And while looking at, like I showed you this kind of things, just wanted to show that we have got different tools now. Flood inundation mapping we can do, air quality index mapping we can do, mobile mapping we can do. We can have a LiDAR survey, we can have aerial data, or we can have satellite data to mark these things. And all these things can be shown in Google Earth or in our web GIS. We can show each and every locality. We can also have some thermal camera to check that which are the area and what is the thermal distribution, or and then we can also show several such layer, electricity line, and like which is being shown over here. If we take simply a photograph thermal camera, which are available now, many of the mobiles are having thermal camera, even LiDAR camera they are having. So if you take the photograph and if you show in the screen, you will see that where the temperature variation is there, where there is a likelihood of, short circuit and other things in such kind of situations. So we have got various tools. And what are the impact that it is causing? These also we have been able to categorize, discretize, analyze, decision making, everything we are taking in a city when a project is given, or like air pollution in Delhi is a big issue, and for that some grant has been given to the institute, I think IIT Delhi or many other institutes they have made, and they have established some of the system to have a continuous checking of air pollution. That is one aspect. And during November, December, in many other cases, directly we put some kind of water mist into the air to reduce the air pollution at that time. Then, of course, the most impending problem is about the burning of fodders or something like that, impact of that and flow of that, modeling of that, and how burning that smoke that which is billowing from the ground in the nearby states, that we are also model it that the smoke that which has come out of the fodder, from there we can track them. We can track them. And then finally, with the wind, that where it is going, which part of the country, whether it is coming to Delhi, exactly the place at Manavrachana University or not. We have got all this kind of tools and technique and modeling and that to track that particular, say, smoke that which came up and came up maybe traveling 100 kilometers. We can chase them, we can identify them exactly it is coming to the Manavrachana around or not. That kind of, computational as well as surveillance power that we in the academics and research and in the industry, we have got all these tools and technique. But the road traffic impact, like something like this, like I have shown you that there are certain kind of barriers are being placed in most of the flyovers in Delhi or even in many other cities or metro cities to reduce the sound effect to the surrounding people and locality. And then odor effect, like in case of sewage, where it's drain, or even some factory, something that how it is causing impact to the society. Then radionuclides dispersion. There are many, there are several such things that you can list out, and then how they are causing to impact, health impact, or any other impact, sound impact or something, or whether they are causing some kind of health hazard for the long term, which remain undetected till it reached to the critical stage. So many things that we look into. And of course, so here the thing is risk. We don't have to wait till all these things, consequence assessment, toxic release modeling. Like I said, this thing, toxic release, if it is there, we can model it. Fire modeling we do, risk analysis also we do. So all these things that separately we do, there are several agencies and experts are there in the country and abroad. If you want to take help of this one, or if you make certain kind of research in this area, door is wide open to motivate the students and teachers and research group to look into something. Again, I say that beyond pure academics. After getting the pure academics, after going through the corridors of academics, then world is quite open to do the risk analysis involving this environmental impact, all these things, which is, I should not say beyond civil engineering, but this is under the ambit of the engineering that we are meaning to or giving to our students. Some of the emerging area for DR. So I'll take, I think, it is already. So it is already, time is over, but I will leave over this to next slide, that like some of the emerging area for DR. One thing is like I said about that 95 lakh bridges are there. So rapid visual screening, mobile app, and then using Google Earth, we can identify their location and then decorate them, geotag them. When we are geotagging our mobile number to so many of the free software, whether it is social media software, whether it is Google Earth, whether it is Facebook or anything, or Twitter, we are geotagging our own location, or while going through Google Map from one location to another locations, they are able to track it. And when we are giving our data, our location freely, why not we just extend, or why not we make 95 lakh bridges to geotag them with the information about the photographs and other things, and make a program that across the country that let us make a robust, just a software is already school kid also can make for taking this database. It is crowdsourcing. Doing that thing, we can get at least rapid visual screening of all the bridges, and there are 30 crore building units are there in our country. So similarly, we can extend our things to checking, having the coordinates of each and every building. Of course, when we open the Google Earth, we can locate our village with my location or everything. Only thing that we have to make using ArcGIS, we have to geotag them, which I think more than 1 lakh students and teachers and faculty members available in the country. Only thing is that we do certain kind of workout exercises, but let us bring it beyond that routine exercise, bring it to the usage and need for the country, that where our bridge, road or railway, they will be very happy to get these services or this kind of information made available to them, so that they are able to give better services. And for that, no money is required. No money, no special requirement of grant is required, because most of the tools are available. Even if some grant or something is available, something is required, it is always there. Grant is plenty. Thing is, come with this idea of taking a responsibility and do it together. Earthquake early warning system. You can visit IIT Roorkee site. Recently, they have installed this one for Uttarakhand, one part of the Uttarakhand, where you will get some kind of message that earthquake is coming. Today also they gave a message. If you register into their system, then for the Uttarakhand area, they are giving some message that yes, earthquake is coming within few seconds, which they will indicate. Then building codes for earthquake safety. You can conduct a similar kind of program, or even faculty development program, which we offer such kind of things, 3 days, 5 days capsule on each of the program that we offer in this area, or many other areas are being added. Drought resilient measures and groundwater recharging, then landslide mitigation by bioengineering, then early warning for glacial lake outburst flood or landslide lake outburst flood, a case study of Chamoli debris flow, which happened on February 7. Natural cleaning of lakes and sewerage, I'll show you by whatever system or by some other kind of natural system which is going on across the country. The cleaning of the water in situ by this natural cleaning system is a wonder in this wonder and disruptive technology using our natural resources, no chemical, nothing, which otherwise by conventional system we cannot do. Conventional, I mean sewage treatment and other things, they cannot. So rainwater harvesting by flexible storage system, I wanted to show that we can make this flexible storage system not 5,000, 10,000, 5 lakh, 10 lakh, much bigger than our elevated water tanks, sometimes dotting our most of the metro cities. But this storage system using flexible membrane can be made them using the membrane that we have on any area that which is having flood water. We just arrest them in this storage using the membrane. Then geosynthetics for hill area development, river flood control measures by whatever system. It is a grass that which we know the country has given this as a nature's wonderful gift for the mankind. You can see many such application of this grass even in my social media also, Facebook. Early warning for thunderbolt, which we do not have, but now there is a company from USA and many other company. They are giving this service to some of the states in the country, including Karnataka, Andhra Pradesh, West Bengal, and some of the things about the thunderbolt, they give 30 to 40 minutes of early warning before it strikes the ground with 90+% accuracy. Not only that, it is warning, but 30 minutes is a time that you can be, and it gives with an accuracy of plus minus 30-40 meter. Means when it is coming that after 30 minutes, thunderbolt is going to come down at this place. So 30 meter moving, go out of 30 meter, 100 meter in 30 minutes of time is good enough. It is not in seconds. Not only that, many of our establishments, there are available in the market, lightning arrestor is also there. So lightning will not happen. Ham radio and wireless communication during mass congregation, retrofitting of buildings, community-based flood inundation mapping, like I have mentioned about flood inundation mapping, or mapping of the building, or mapping of the bridges using Google Earth. Living with extreme heat, technology improvisation versus traditional system. So there are many such programs you can see in the NIDM website that were every day 3, 4, 5 programs, online programs are going on. So you are most welcome to see, take free, it is all free. You can register and you can take part. Hundreds of programs are going on, started in COVID period, especially online program from April 10th, 2020 onward. So we are moving fast in the health analytics and much footage in the health assessment of infrastructure. We are also having this kind of IoT systems and other things. We are also having this kind of buttons, panic buttons, or sensor, COVID-19 tracker using carbon dioxide monitor, using this kind of things. Air quality sensor, this can be fixed or this can be mobile also. It doesn't need anywhere. It is through radar communication. It can have some kind of this kind of button. These are all ready-made industrial products available. It can count how many people are there. Like I'm sitting in my room 1. If you are having a meeting, how many people are there? It can count there. Even in, so it can track also, like mobile tracker or GPS tracker is there. So these also are able to track all these things. There are hundreds of such devices now available in the market. Only you have to choose them, that where to use and how to use them. Okay, I think only thing that, oh yeah, I wanted to highlight that this is like my Facebook item. Now it is more than 1670 items are there. So with all the, as I said in the beginning, most of my slides are there in the Facebook with such kind of explanation that whatever I think that is suitable, whatever my mind comes out, just with explanation that you can see all the slides with the numbers starting from 1 to now 1670 such are there. Date-wise, you can see in the Facebook. And with the comments that which doesn't, with malice towards none, showing over here that this kind of buildings are very, very dangerous. In earthquakes, several thousands of buildings already taken. Broken means this car also gone. So what scientists or civil engineers have done, they have made a replica of building or frame of 6-story building. I am giving you that video, rather it is available also. A 6-story frame building tested in a shake table that fails at the bottom. So what nature has told us, gave us the lesson, and we should not make steel building, but there are ways to make steel building also earthquake resistant. We have to put some kind of wall in between, so that shear, whatever shaking is there, it should not exceed the tolerance limit. So we can make this kind of building again resilient enough to shake. But when it is not there, simply a frame building is there, without any filler wall or any almirah or anything is there, it is failing here because performance, it is design wise, it is perfect. but performance-wise, it is not. So this is again showing you, and this is the kind of construction that we do. And this is the failure, no column is given, 2005 earthquake in Kashmir, Uri area. And we make such kind of buildings, and due to earthquake, that what will happen to these joints? We know what will happen, but we do it. We make such kind of things also, which is not according to the things. It is just, okay, something retrofitting has to be done, so do it. No. So anyway, I wanted to say that you can see some of these user manuals and reports that which are automated. Field survey forms. Forms are given for seismic vulnerability assessment. So 5 IITs joined hands, and it is available, you can see. And what are the database that they are keeping also are there, because structural strength damage, existing damage observed, history of earlier damage, all these things are being noted. So these are taken from that report, that RVS, Rapid Visual Screening, where these softwares are already there, and accordingly the survey can be made. And we also made like 10,000 buildings surveyed in Delhi. Then we have made this survey, very simple one, yes, no, not available, unable to comment kind of things. So some 25 questions and this kind of survey is there. And we have made all those 10,000 building data into a software in 2011 itself. And then put all the database here itself. So 95 lakh breeze, which I'm talking about, if you want to make those database, then you have to make a software to contain all those all those data. So in this case also, 10,000 building, each building is having 350 such data component. And we have made a searchable file as well as report, automatic report generations and everything. These are the unique ID that we have given, RVS like ward number 221 and building number 10,701. So it is ward, area in East Delhi, house number. Then we have uploaded all those things, all the survey report, and then we have made a searchable file in terms of, building identification. It is Shadra district, south and north and East Delhi. And then if you put ward name, if when you are putting, it will auto search out which is the colony code, which is the house number, block, face and everything. You can submit the entire building details, data, observations, photographs, everything will automatically come. And we can see that for each of the 10,000 building, we can get separate report, which is already there here in a PDF format, but which we have made into a program, into a Excel sheet. Any data, all the building related information can be brought in the Excel sheet, and it is a searchable file like that. So this is the lake water, which is in situ treatment going on. And during treatment, just 15 days back, this is the condition of the water. This is few days, 15 days back. So this operation is going on. And then I have got specimen of these things in a bottle. And this bottle, these are the things 15 days before. It is there in my room, I can show you. But now they started cleaning. You see the color over here. You see that all are same here. It is taken from here. These are the in situ treatment being done. And in fact, we need to have some research laboratory where they can check BOD, COD, dissolved oxygen systematically for these things. You are most welcome to join immediately. To take this specimen and do the, in the environmental engineering laboratory, check pH level and other things. For another 2 months, this test will go on. And then we can correlate that systematic changes of the cleaning of the water by this process. Like this is also in last year, June, July. This is before treatment, one of the lake in Rohini nearby. It took about 3 lakh rupee to change it to this way in 1 month of time. I think I have taken the time, but oh, already time is overshoot. So I want to leave here. There are many other technology, disruptive technology is there, but things that which we can do where it doesn't involve money or anything, but needs a coherent appeal to work together for the resilient India, not in terms of number, but in terms of quality work beyond, again, I'm telling, pure academics in the classroom. Thank you.
Thank you so much, sir, for this informative session. And I think the way you explained each and every aspect of the disaster risk reduction, I don't think anyone can find it any literature, whether it's any book or any research paper, because you know, it's like all practices which is actually going on site. So I think it is definitely you know, eye-opening session for everyone. So there's few questions, sir. I'm just gonna take, yes, 10-15 minutes more of yours. The first question that comes is that how the risk of liquefaction of soil on structure can be reduced or controlled?
So I have to take another at least 2-hour session on this, especially on this.
Okay, so I can.
Because there are a lot of mitigation measures are there.
Hanji.
There are lots of, one thing is, the pore pressure that which develops, which causes the liquefaction, that is to be, pore pressure should not develop beyond the limit, you know, overburden pressure or whatever it is. So in order to do that, because the water is not able to drain out. So one way is that to put some kind of geosynthetic weak drain or some kind of drain inside the soil, which is likely to liquefy, like the photograph that I have shown in case of earthquake in Assam. So their liquefaction occurred because there are 3-4 liquefaction causing factors are there. Water table is nearer, soil is sandy, silty, and earthquake shaking is 6-7 or something like that. So if that is there, it will, and it is nearby the water body or like Brahmaputra river, or it is a basin, that area is there. So that is why it has happened. So in order to that, because we have to, when liquefaction we have to stop, then first thing is we have to go for soil exploration. Then we have an indirect method of determining whether soil is going to be liquefied or not. So there are, since 1968 onward, all over the world, including India, there are millions of test evaluation papers being published to check beforehand whether an area which you are going to construct a road, building, tunnels, or whatever establishment, field or anything, whether it is going to be liquefied or not. So we have some indirect method of giving or assigning, telling that liquefaction will not happen or will happen. So there are a number of papers, research papers are there. But main thing is how to control liquefaction. So it is only that we have to densify it to such an extent that even shaking is not going to disturb the loose soil. The soil has to be loose, then only liquefaction occur. So in that we have to densify, that is the most direct one. Another thing is when we see that all these 3 aspects are there, water is going to develop the pore pressure, then pore pressure has to be released before it goes beyond that critical point. So in that case, we have to facilitate certain internal drainage, whether it is in the hilly area or whether it is the flat area, the ground area, or in the locality itself. So we have to have internal drainage functional, so that as soon as vibration comes, that pore pressure will be released. And if we can establish that, then liquefaction will not happen. And also, there are liquefiable zones are there. So there are certain construction where we cannot do this kind of internal drainage. Then we have to make certain kind of structure like pile in a liquefiable area. We have identified, say, 3 to 5 meter liquefiable area. So then we go for design of those kind of deep foundation which will not be affected by liquefaction of this liquefying zone which we have identified. So that load is being transferred beyond the liquefaction zone. And so there are many ways to avoid liquefaction or to facilitate liquefaction without causing damage to the structure.
Okay, sir.
In short, I would say.
Okay,
There are many
sir.
other ways are there.
Okay, so no, sir, I will keep this topic, and then we will want you to give another session someday on
In
this.
fact, I want to show that, just a minute. Yeah, in my room, this is a research done here itself. I can create liquefaction over here.
It's wonderful, sir.
One research paper is coming on this.
Okay.
It was done actually in my room itself
Okay.
6 years back. What is this? This is water. This is a Coca-Cola bottle.
Ji.
This is Yamuna sand. Just the sand where Noida, Greater Noida area is having a sand up to 9, 10, 12 meters. And there we are making multi-story building with 2-level, 3-level of parking, which are very, very dangerous. But nobody cares. So that sand, here you see what we are doing. Here some rubber ball are there. It is just bought from the market. Then there is another one you can see with a pin, which is a building.
Okay.
So what I am making here, and you will get a full video here I have shown over this. So I am holding it here. So you see, let it be little clear. Those two rubber bulb, which is little heavier than water, they are inside the sand.
Okay.
Can you see that? Can you see now? You cannot see.
So your bottle is near to the screen. I'm just going to keep a little bit away from the
So,
screen.
Okay.
Away, sir. Okay, yes, it is visible.
You can see.
There,
Yes, sir.
you can see one, and if I make earthquake like this, like you see, they have come up. This one has come down.
Yes, sir.
This one has come down.
Yes, sir. Yes, sir.
So this is the underground utility which comes up, like drain pipe or sewerage pipe. They go up, and the overground things come down. You can see they come down. So we have done a series of experiments on this.
Okay, sir. Okay.
Which is going to come in a journal paper soon.
Okay.
Visualization of liquefaction, and also you can see, that is what I said. These are the pipelines through which we measure the pore pressure. Through this it comes up water. So through this it comes up. So we measure the pore pressure also. We have taken all these visual things.
Okay, sir. So second question is there, what is the main factor that hampers the performance of this risk reduction in the developing nations like India? Are any, it's like how the performance is being hampered?
Which one?
What is the main factor that hampers the performances of risk reduction in developing nations like India?
Is it a question from a civil engineer?
I don't know. So I just received a text from, from the group.
If it is a civil engineer, I think I will not entertain answering this question.
It's fine, sir. Then we should leave this thing.
Have you got what
Yes,
is the tone of an engineer should not speak in this manner?
Yes, sir. Yes, sir. And there is one more question is there, that any risk management systems are forecasted for any climate change also, if you are going to consider a global warming aspect.
A lot of things are there. In fact, I had shown not even half of the slides because time has gone up.
Yes, sir.
But I would say that you can have one webinar for 2 hours. Then
Okay,
I'll show only those things only.
Yes, sir. We will definitely have
Okay.
another session.
So we can have a webinar. We have series of webinars you can see, but this aspect especially that I can show you these things.
Sure,
There
sir.
are many ways that we are measuring. And
Okay.
even during discussion, I said that we are able to monitor, even predict, and even the pollution, where it is, even viral infection now, that the COVID virus, where they are concentrated, we can track them. A hospital where so many patients are there. So we are able to track the pathogen, disease-causing pathogen, along with so many people are coming in the emergency or even in the outdoor. So we are able to measure that within hospital, within 500 meter in the hospital, you will see that how many people are getting impacted due to the hospital-induced health hazard, because people are coming from various parts of the country with various ailments. These are all surveillance is being done with the IoT and with some kind of devices that which we have to put, which are mobile.
Okay.
So these things are there. Only thing is that we are still lagging behind more than 2 decades in adapting these things, not buying things. We are buying iPhone 12, 1 crore or 1 lakh or something. But owning that, understanding that in the academics and research, and then developing our own thing is the main aim of this kind of training program and education and research, which we have to start now. Or already it is going on in many of the institutes.
Okay, sir. Thank you so much, sir, for your time. And I think indeed it's a lovely interaction with you. And, I think the participants are also getting a lot of information. As you said, we'll definitely going to invite you again on the 2 or 3 topics that we just, discussed. So I just want Dr. Sunita Bansal ma'am to kindly give vote of thanks to sir. And Dr.
Sir, good evening, sir. Sir, Sunita Bansal here. Sir, it's always an enlightenment and such a pleasure to listen to you on all disaster issues and all the practical aspects of safety in the buildings. It's always been such a pleasure and an enlightenment, sir. And I'm sure that we all will get together and build a resilient India, definitely, for sure. And not many of us actually knew about the building identification database that you have just shared. And I'm sure it's actually a long way to go, but then efforts are on, and National Institute of Disaster Management is doing tremendous efforts. Sir, thank you so much. In fact, morning when I couldn't get you through, so I was worried, and we couldn't have got such a vast knowledge from anybody else other than Professor Chandan Ghosh. Sir, thank you so much, sir.
No, knowledge is what I wanted to emphasize through our teaching fraternity is that we have to come beyond the classroom. Yes, and motivate the students. They are excellent students. They are coming with so many facilities that they are having. Only they have to think laterally, think beyond. After taking the basic knowledge, they have to think about the society. Then only our knowledge will be helpful to nurture the society, this wonderful gift that the nature has given to us to sustain.
Yes, and this simple,
so let us work together.
Simple experiment on liquefaction, because in our college we always are cribbing about the equipments that we don't have, or maybe
here you see, here also one ball is there. This is a coarse sand. Yes. This is a coarse sand, you can see, but here you see, if I make this one, And those are, you see. So here, if I make it also, no liquefaction is no, those balls are not coming up. Out of 3, 1, this was there, but rest are inside. Even though you see that they are there.
Yes, sir.
Whereas in case of Yamuna sand, wherever they are inside, they will come up.
Yes, sir.
They are susceptible to liquefaction.
Simple depiction of liquefaction and such simply, explained, sir. I wish we could have more of you, and we will definitely plan more webinars on this. Sir, thank you so much, sir. Pleasure, sir. The department is actually honored, sir. Thank you so much.
Okay. Namaste.
Okay. Thank you, sir. Thank you. And thank you for all the participants. The feedback and attendance form is already there in the chat box. So kindly fill it up. And tomorrow we will again going to start the session from 9 a.m. We're going to have the session of Art of Living by Dr. Shobha Srivastava. And I think tomorrow we'll be again going to be having a mixture of internal wellness and the software applications of GIS. So thank you once again, and thank you so much, sir, for your time.